or the next state variables, and we try to determine their equations. So now y1 is a function of small y, which is the present state, and the state and the input variables to the system. Okay? So I have y1 here, which is this or this or this, representing the value of y1. So therefore I have it here. So the analysis now is to determine the next state variables as a function of present state and the inputs. Okay? Now we take these equations and we put them in a Karnaugh map. Okay? So by emptying them in a Karnaugh map, we can tell whether this circuit has a hazard or not. For instance, we can see that the production of Y1 does not have a hazard. However, the production of Y2 has a hazard. Why? Because there is a product term here that is beside another product term. What does it mean beside? That means one variable change in the input, which is allowed in a fundamental mode, will cause the circuit to go to the next product term. In doing so, it might switch to 0 and then back to 1, which is a hazard. So therefore, you can look at this because you see them beside each other. You know that you have a hazard, and you can see this to be beside this one because there is only one variable change, which will cause it also to go through a glitch. Okay? So therefore, by looking at the circuit in an analysis exercise, you can tell that your circuit has a hazard. To get rid of this hazard, you will have to create another product term which will join this to this, and another one that will join this to this. Otherwise, you would have a hazard. Yes?
You just covered both hazards with one square hazard function. What if you covered both hazards with one square?
Okay, so you're saying that I will just take this with this, is that right?
Yeah.
That works too. Yeah, very good. Any more questions? Yes?
Is this going to prevent load the static and dynamic hazards?
Question here. Are we talking about dynamic or static hazards here?
Static.
Yes, that prevents only static. Doesn't prevent dynamic this way. Now, analysis again. Okay? Now, we go to the same circuit that we have here. We create the state table. And now, we look at the different states and see how they behave as a function of the inputs. Okay, so that's very important for us. Why do we do that? We would like to determine if the circuit has a race and it has a stability issue. Race and stability are the next ones. Okay, so we would like to make sure that the circuit operating in the fundamental mode, it does not get into a race situation. So let us see what happens. Assuming, and by the way, this was in one of the final exams before, where a table like this was given to you, and the question was, determine if this circuit has stability issue in it or not. So assuming that we started at, am I right here? Yeah, okay. Assuming that we started at state 1, and the input 0, 0. So we are here, and the input 0, 0. So we are going to stay at 1, 1. That's fine. Okay? Now we change from 0, 0 to 0, 1, which is a fundamental mode that's allowable. So we go from 0, 0 to 0, 1. That means we go from 1, 1 to 0, 1, and then we go and we settle here. Okay? So the present state then becomes 0, 1, and the Y map indicates that the next state is now 0, 1, and the system has reached a stable state. 0, 1, 1 to 0, 1 to 0, 1, and we are okay. Good. So, just repeating this again, this takes me to 0, 1, and back to 0, 1, and I am settled here. As long as my input is still at 0, 1, because I changed it from 0, 0 to 0, 1. That's how asynchronous circuits work. Assuming that I am at 0, 1, Okay? And that's how you analyze it. Take one state at a time and see what happens given one input change at a time. Okay, so state 01, the input goes from 01 to 11, which is a fundamental mode input. So now we go from 01 to, so we are here, and our input changes from 01 to 11, which means that we go to 00, so, which is a unit distance. 01 to 00 is a unit distance in terms of bit changes in the state variables. Now we go to 0. Now that will give us 01. When we are here, will send us to 01, and so on. So you can tell that although we are working in the fundamental mode, we see that the circuit is going to go 01, 00, 01, 00, and it will never settle. So the circuit is unstable because you cannot rely on it to go to other states at all. It just keeps going between the two states and does not settle in any state to produce the desirable output. Okay? So we go from 11 to 01 and then 00, 01, 00, 01 and so on. So therefore it is unstable. So this circuit has a stability issue. Okay, now let us say we are at 01. The input changed from 01 not to 11 but to 00. So when you look at the big Y map, it indicates that my next state is going to be 10. So in this case, we went from the present state 01 to 10. As soon as you see that, you determine that your circuit has a race. But does this race create a hazard or critical race or not? That has to be determined. So there are three possibilities here. Okay, so we'll have to tackle all of them. So in going from 01 to 10, we might go 0111 or we might go 0100, depending on the timing. Okay, for instance, if this one does not change quickly, then we will go to 00. Okay, and that's one possibility. Or we go to 11 if one of them is faster than the other. Like this one changes faster than this, that means we'll go to 11, and that's something that we need to look at. So now when we look at the system, the table, we see that if we go from 01 to 11, we will sit there and it's a stable state. If things didn't work that way, but we went from 01 to 00, then we are stable at 0. If things went from 01 to 10, then we end up at 11. So is this critical or not? Yes. It is critical because it took us to different states depending on what happened in the sequence. So we are under the mercy of the sequence, therefore this is a critical race. Okay? Okay? They are not supposed to change simultaneously. And that's the thing is that when you go from 01 to 10, 01 to 10, that is 2 bits changing at the same time. If we can guarantee that, then there is no problem because it's perfect timing and we are getting, the problem is that 01 to 10, maybe one of the bits will change faster than the other, which means the system will have to go through different values. So you cannot ensure that you cannot guarantee that. So that's why the only way to do it is to make sure that you don't get your system to go from state to the other where you have 2 bit changes at the same time. That's the only way we can do it. Yes? Which one? No. No, we are saying that if the present state is 01 and the input changes from 01 to 00, which is 1 bit fundamental, but what happens